10.2 at volume and surface area of three-dimensional shapes. Okay, 10.1, we focused on two-dimensional shapes. Okay, we did perimeter and area. Okay, and then now we're doing three-dimensional with volume. Okay, so first I'm going to define these terms. So I'm going to actually, we'll do a text box so it's nice and neat. Of course, the phone rings as soon as I start recording. Give me 1 sec. Actually, did that stop ringing? I guess they maybe called the wrong number. Okay. All right, so we're going to define surface area as the total area of the surface of a three-dimensional object. Okay. Okay, you're covering the outside of the shape. So think about wrapping a present. You're covering the outside, or painting. Like if you're painting something, you're painting the outside of it. Okay. You're covering the outside of a shape. That's the surface area. It's all the space, the flat sides and faces of the three-dimensional figure. All right, now the phone's ringing again. Hang on. Verify. Good, thank you. Okay. Okay. Okay, which office is it? Where are you? 100? Oh, thank you. Eduardo and Jefferson, 100. So run down there real quick and then come back. Okay. So again, that's like painting or covering, like wrapping a present, the outside of the figure. Make that a little bit smaller so we can fit in the volume definition underneath. All right. Now volume, the volume is going to need to be bigger than that. Excuse me. The volume is the amount of three-dimensional space an object, bless you, occupies. Okay, it's filling the inside of the shape. Okay, so think about filling a glass with a drink, okay, or a pitcher or something, or filling a pot with water, or a can being full of soup or something. It's the space that fills the inside, okay, or a box of rice or something. The inside being filled up, that's volume, okay? Volume is inside, the surface area, that is the outside. Do we feel okay about the two definitions? All right, underneath this is a bunch of formulas, okay? It's just a lot of stuff you have to be able to read and apply. There's not really anything for you to add here. I will try to do a little color coding here for us. So the area of the base of the figure, that's going to be the capital B. You'll see it in the surface area of a rectangular prism and in the volume. Well, it'll let me highlight that B. There we go. You'll see it in the volume of the pyramid. Now, technically, it's also in the volume of a cylinder and cone, but what shape is the base of a cone or a cylinder? A circle. And we know that the area of a circle is pi r squared. So you can see in these formulas, instead of putting that capital B, they went ahead and just put pi r squared because that's area of a circle. But really, that's the area of the base. The base just happens to be a circle for those two shapes. Okay, and then the height has to be perpendicular to the base. We talked about this in 10.1 when we did area. We said the height, the base and height of a shape are perpendicular. So same thing applies in a three-dimensional shape. The height measure has to make a 90-degree angle with the base. Okay, so it has to be perpendicular. If you want to add a little sketch here to the side, if you forget maybe what that word perpendicular means, you can just draw a right angle, and it's usually marked with a little box like that. So the height and the base have to make a 90-degree angle. That's what that's telling us. Okay, now the R is radius. We know that. We talked about that in 10.1. Okay, so the radius is from the center to the edge of the circle. Okay, so it's halfway across the circle. Diameter is all the way across. Radius is halfway across. Come on, highlight. Just the R. There we go. But you use the radius to find the area of the base in cylinders and cones, since the base is a circle. Now, a cube is a little different. You could use rectangular solid for cube as well, because a cube is a rectangle technically. But in a cube, all the sides are squares, which we know all the sides are equal in squares. So you can just do side cubed instead of doing length times width times height, okay? Which is what base times height is, because base is length times width. So the volume of a rectangular prism, you'll probably more familiar with seeing it as length times width times height. Area of the base is length times width. If you want to write that down, you can, okay? So let's try to apply these, okay? You'll notice I left surface area formulas blank for pyramid, cylinder, and cone. Y'all are not going to have to calculate those. The only shapes that y'all are going to find surface area of are going to be rectangular or cube, okay? So for those, we need to know surface area, but the rest, it's just volume. Okay, so let's start with a rectangular solid. Okay, we've got a rectangular prism. The first thing we want to identify in all of our 3D shapes is the base. Okay, now it's usually sitting on the base, not always, it can be drawn differently, but I'm going to just use this side that it's sitting on as the base. So this rectangle that I shaded in red is going to be my base, which is 18 by 3.5. So for the area of my base, I have to do 18 times 3.5 because the base is a rectangle and that's length times width, right? Is everybody okay with that? So I do 18 times 3.5, which gives me 63 for the area of my base. Okay, I'm gonna go ahead and jot these formulas over here again. Remember, surface area is the height times the perimeter of the base plus 2 times the area of the base. Okay, so that big B value, that's gonna go here. So that's gonna be a 63. Now the height is the distance between the bases. So this third dimension is the height. I already used 18 and 3.5 as the length and width. So the third dimension height is 15. Now I just need to find the P, which over here it tells you P is the perimeter of the base figure. Okay, so my base is this red rectangle down here. So I need the perimeter of it. Go close the door, Jefferson. So the distance around it. Okay, so all of these edges of this rectangle added together. Okay, so to find that perimeter, I can do two things. I can just add all four sides, or I can do the formula where it's 2 times the length, so 2 times 18, plus 2 times the width, which is 3.5. So I can calculate this perimeter. 2 by 18 plus 2 by 3.5 is 43. So the perimeter of the base is 43. And now I can calculate the surface area. So my surface area is 15 times 43 plus 2 times 63, which comes out to 771. So the surface area is 771. Now units, we didn't discuss units yet. When we did perimeter in 10.1 last week, perimeter is one dimensional. It's just the distance. Okay, you're just counting, adding up all the distance. You didn't multiply anything to get perimeter. So perimeter would just be in inches. Okay, area, you're multiplying length by width. It's two-dimensional. 2 dimensions are being multiplied. And so your area is in units squared. Now, then volume, you multiply then by the H, and you're multiplying 3 dimensions. And so the volume is, your units are cubed. Okay, now surface area is still going to just be squared because I didn't multiply the area of the base times the height. I added those together. Okay, so even though this is a little more complex than just area, the units are still squared. Area is units, and I'm not going to write units because they told me inches. So I'm going to write inches, or IN. Okay, but it's going to be squared, inches squared. I'm going to add that up here next to the definitions, the units. Okay, so surface area is units squared. Volume is units cubed. Units squared for area, units cubed for volume. Okay, my units in this one are inches. All right, now volume is area of the base times the height. Well, we already calculated the area of the base to be 63. And we already calculated the height to be 15. So now we're just going to multiply those to get the volume. So 63 by 15 is 945. So the volume is 945. Now this is the space inside the shape. This is how much it's going to take to fill it up. So this is your units, which are inches, cubed. So to the power of 3, because it's 3-dimensional. It's to the power of 2 when it's 2-dimensional. All right, we feel okay about that one? Now the rest of these, you can see this box on the left is grayed out because for these next 3, we're not finding the surface area. We are just looking for volume. Okay, so I want to find the volume of a pyramid. Now a pyramid is going to be a third of the rectangular prism, okay, because these sides are cut on both sides, you have pieces cut out. So the formula is similar. It's area of base times height, but it's a third of that. Okay, but I'm still, that B still represents area of the base. So my base in this one is this square on the bottom, and I can see it's 28 by 28. So I'm going to calculate the area of my base, and it is 784. Now, where this one gets tricky is the height. Because this that they have labeled 22.1, see how it's coming on the front edge? It's like this front triangle where it's drawn to this base side on the edge. Do y'all agree? Okay, it's not down into the middle. Okay, the height would be drawn from the top straight down to the middle of that square. Okay, because then it would form a 90-degree angle, okay, with this base, which the 28 or the 22.1 does not. So I'm going to draw this out to the side here. Okay, the height would come straight down to the base. Okay, and then this is the slant height that's drawn down the front. So this is the slant height that's 22.1. I want to know the actual height that makes the 90-degree angle with the base. Well, if the base is 28 across, what is halfway across from the middle of the cube? What's half of 28? 14. Okay, so this is this triangle inside here that I've just drawn out to the side. Okay, now we just tested in Unit 9 about finding the missing side of a right triangle, didn't we? What can we use to find the missing side of a right triangle? Pythagorean theorem. A squared plus B squared equals C squared. Remember, this is what we just tested on. Okay, and we said that the C has to be across from the 90-degree angle. That's the hypotenuse. And then the A and B are interchangeable, the H and the 14. So this could be H squared plus 14 squared equals 22.1 squared. Okay, so 14 squared is 196. So I have H squared plus 196. And then 22.1 squared is 488.41. And then I would have to subtract the 196 over. Which gives me 292.41. And then to get rid of the square, we have to square root. So the opposite of a square is a square root. So to solve for H here, I do the square root of 292.41, which is 17.1. So the height of this pyramid from the center of the base up to the tip is 17.1. Now, you're not going to have to do this extra work every single time. Sometimes when they label the pyramid, they will label this height up the center. If that is labeled, then you just plug it in. But if they label the slant height, and I'm going to label that here. This is the slant height, then you have to do Pythagorean theorem. Okay. All right, so when I calculate 17.1 times the 784 times the 1/3, this comes out to 4,468.8. This is volume, so our units are cubed. Our units are in meters. That's what the M stands for. So this is in meters. Oh, I just said cubed and then I wrote squared. Cubed. Volume is always cubed. All right, now we're going to look at the two that have circular bases. So a cylinder and a cone. Now this cylinder is on its side. It's not sitting on its base. The base of a cylinder is a circle. This is like a can. It's just laid on its side. Okay, so the circle is the base in both of these. Okay, one of them is sitting on the base, one of them is not. Okay, but the circle is the base. So here, the area of the base is that pi r squared. Okay, well, the radius is from the center of the circle to the edge. How far is that radius if all the way across is 16? What's the radius? 8. The radius is half of the diameter. Okay, so the radius is 8. So I'm going to do pi 8 squared. Now, I'm going to leave pi. So 8 squared is 64. So I'm going to just say 64 pi is the area of my base. Now, the volume can be written as BH, or how it was listed up there. Instead of B, they wrote pi r squared H. Okay, now I already calculated this pi r squared to be 64 pi. If you want to show over here that we plugged in this 8 here, you can show it over here again. And then the height is the distance between the bases. It's on its side right now, so it looks different, but the height is that 13. So when I calculate this, I'm going to do it once with just the numbers. I'm not going to type the pi in. I'm just going to do the 8 squared times 13, which is 832 pi, because I didn't type the pi in. The pi is still here. And my units are centimeters, so volume is centimeters cubed. This is what we call the exact value. You leave pi in the answer. Okay, if it says in terms of pi, that means leave the pi symbol there. Now, if they ask for you to round the answer, you'll do the 832 times pi, which if you are using Desmos, you can just use the pi button. If you are using a 4-function calculator, you'll type in 3.14159 for pi, because we're going to get as close as we can. So I'm going to make a note down here. For pi, I want you to type in 3.14159. That way your answers are as accurate as possible, and you're not really getting a rounded answer till the end. Okay? All right, same idea here. Oh, need that decimal back. Got the area of the base. Let me write the formula again here. This one is a cone, so it's going to have that 1/3 again. So you can write it as 1/3 B times H. But remember, the area of the base, so when it's a circle, is just pi r squared. Okay, so the radius here from the center to the edge is going to be half the diameter of 17.6. So you have to divide that by 2, and we get that the radius is 8.8. So in place of R, I'm going to have 8.8. The height, remember, makes the 90-degree angle with the base, and that label was marked as 90, so I know that's the height. 23.4. I don't need to do anything fancy to find it. It's labeled. So I've got 1/3 times pi times 8.8 squared times 23.4. I'm going to multiply all the numbers. So 1/3 times 8.8 squared times 23.4 is 604.032, and I still have pi there. Now my units are inches, so this is going to be inches cubed. Okay, again, that is the exact value. Now I'm going to round. I'm going to type 3.14159 in for pi. And I get 1,897.6 approximately. And that would still be in inches cubed. So if you have a circle, so cylinders and cones have circle bases, you may be asked to leave your answer in terms of pi. You may be asked to round it to a decimal. Okay, so you have to read your instructions carefully. Okay, if you are rounding it to a decimal, in place of the pi symbol, you can type 3.14159. Y'all feel okay about this? Okay, you've got practice in Delta Math. I will pull it up here. Here's the calendar, just a reminder. We took that retest for Unit 9 yesterday after the glitch last week with the original test. So check Skyward to see how you did on the retest. If you need to do corrections to this, you can. I still have some people who need to make it up, so that's not open yet for corrections, but hopefully everybody will make it up by tomorrow. And I can open up the test for you to see the results and do your corrections. We're going to finish up the Unit 10 notes this week. You've got a 3-day weekend, no school Friday. Then we'll come back. We'll have a work day to finish any practice for Unit 10, a couple review days, and then your Unit 10 test will be next Thursday. Okay. So we're halfway done with Unit 10 now. Your practice in Delta Math. You get the student view. You should see today's 415. Okay, it is 10 problems. There's only one section that's surface area because you're only doing that for rectangular prisms, and then volume of the 4 different shapes we talked about. Okay, so get 2 in each of these sections correct and you're done. Okay, some of you can knock that out really quickly, maybe 15 minutes. Some of you it'll take a little longer, and that's okay. But if you still see this 4-9 assignment on perimeter and area, this is from last week. This is section 10.1. It is still available through today for full credit. If you don't finish it today, it's going to drop to late credit. You look under the past due tab, you still have the Unit 9 assignments, 9, 1, 2, and 3, available for late credit as well. Okay, so take care of any of your late work and get to work on this new volume and surface area practice.